So if, as we are discussing in ACL, that whenever you configure an ACL there, then uh, you can have multiple statements in your access control list. So if one of the statement gets satisfied, like there is a traffic that is coming from 1.0, so in the set of commands that are configured under this access control list number 10, if the traffic is coming from 1.0 and that gets satisfied, the access control list will not execute the second, third, and fourth statement. But if the first statement doesn't get satisfied, then it will come to the second. If second also doesn't get satisfied, it will go to the third. If third also doesn't get satisfied, then it will go to the fourth. And if nothing gets, I would say, executed, then there is always an implicit deny. This is the most important thing to understand. There is always an implicit deny. An implicit deny can be configured like by default. You don't need to do it, and it is hidden there. Okay, you will never see an implicit deny statement under any access control list. It is hidden and by default configured. And what does this mean, implicit deny? This implicit deny says that deny any, meaning deny everything, because nobody or no statements got satisfied. That's why deny everything. So, do you understand what this implicit deny means? 3 and 4 are such statements, like you can say that number 3 is deny, or 3.1 and deny something. That's 3 and 4. So whenever such statements are being configured, you what you need to do is, if none of your statements are passed, then the state is called as implicit deny exactly. Okay, and what happens in implicit deny? All the traffic will be blocked. That's why your second last statement of each and every access control list should be permit any. This should be your last statement. Okay, and that last statement should only be permit any if there is no permit on the other thing, or if there is, I would say, nothing that is getting filtered. So in that case you need to like permit everything, otherwise everything would be denied. So that's where you need to be careful. Do you understand this, guys, of how implicit deny actually works? All right, so we will go and we will see how this access control list actually works, and we will check the same thing in packet tracer. So I'll share my other screen with you and we'll see how it works. Perfect. So we'll just build up a normal topology that we have been using for quite a long time now. The network that we are using over here is going to be 1.0, 192.168.2.0, and 192.168.3.0. And now I'll just go and configure the same thing, and we will also incorporate RIP in this topology so that communication works fine. I'm gonna say no enable conf t interface fa0/0 no shut IP address 192.168.1.1 255.255.255.0 interface se2/0 no shutdown IP address 192.168.3.1 along with the subnet mask. And then I'll take an exit and say IP DSCP pool A network 192.168.1.0 255.255.255.0 and default is going to be 192.168.1.1, and then take an exit and router rip version 2 network 192.168.1.1. sorry 1.0, and we will also advertise 3.0. That's how we are done configuring the rep. Then we will go to the other side and we will specify no enable conft interface a0/0 no shutdown IP address 192.168.2.1 255.255.255.0, and then IP DSCP pool B network 192.168.2.0 255.255.255.0, and then default 192.168.2.1 interface SE2/0 no shutdown IP address 192.168.3.2 255.255.255.0. Take an exit, and then we will go ahead and see the IP addresses. That's going to be DSCP there, right? And then you would also see DSCP here. There you go. Then DSCP over here as well. And then desktop config and DSCP. And there you go. Now, if I try to send traffic from here to here, then it's going to be failed. First packet is going to be failed. Second one also is failed because I guess we haven't done the rep configuration right over here. So what do we need? We'll say router rep version 2 network 192.168.2.0 and 3.0, and take an exit. If we check our do show IP route 3.0, perfect. Then when I send traffic from here to here, it's going to be successful. Correct? Now every PC will be able to send traffic from here to here, and it also gets here to here. First failed, successful. From here to here, successful. From here to here, successful. Make sense? So every PC is able to communicate with each other. Now what I don't want our second PC, which is 1.3, to be able to communicate with the other. Okay. So what I want is my 1.3 PC should not be able to communicate with each other. So what are we going to do over here? We are going to go on the destination router, which is our R2, and we will open up the CLI. Okay. And we are going to configure a standard access control list. And that access control list can be configured by using access hyphen list space. You can use numbers between 1 to 99. So we will just use 10 for our standard access control list. And then we will specify whether we want to deny the traffic or permit the traffic. Okay. So we will say deny. And what do we want to deny? We want to deny any IP address, okay, where we can specify the entire network ID as well, or we want to deny any PC or any source host, or we want to specify a single host. We want to deny a single host. That's why we'll say host space. We will specify the IP address of that host, that is 192.168.1.3, and then that's all. This is the command that it's going to be. Then after that, as you see it over here, we have created this access control list now. But if I kind of send traffic from here to here, it's still going to go successful, and from here to here as well, it's still going to be successful. Now where are we lacking? We are lacking at the thing that we do not just need to create the access control list, we also need to apply it on an interface as well. Okay, so the access control list has a formula that ACL can be applied, or I would say one ACL can be applied per interface per direction. So you need to understand how traffic comes in. If the packet are going to flow from this PC to this PC, it means that it is going to travel to the router, that is R1. And how it is now on R1 there are two interfaces. So the traffic will go inbound, or I would say inside of this FA0 slash 0, and it will go outside of this SE2 slash 0. Do you understand this? Then it will reach out to R2 and it will go inside of this 2 slash 0, and then it will go outside of this FA0 slash 0 to go towards the PC. Do you understand the direction of traffic? Yeah. So you need to understand how the traffic is going, and according to that direction, you need to apply your access control list. Okay. So the direction says that the traffic, whenever you are receiving on this link, the traffic is going inside of SA2 slash 0. Okay. And the traffic is going outside of FA0 slash 0 when it's going towards the PCs that are connected downside. That is exactly how this direction is figured out. So you can configure one access control list per interface per direction, meaning one going outside, one going inside, one going out, one going in. Per interface, one access list per direction. Now we created our access control list, that was access control list 10 deny host 1.3, right? And we will apply this, and you can verify this access control list by running show access list. You can see that there is this access control list that is configured. Okay. And we will apply it onto our FA0 slash 0 interface going outside. So I will say interface FA0 slash 0, and then I will say IP space access hyphen group space 10, and then I would say either in or out. So I will say out and hit enter. And then you can see the traffic, the ACL has been applied on this particular interface. And now if I send traffic from 1.2 to this destination, it's also failed, and 1.3 also is failed. Why so? Because if you check your access control list, there is just one statement that says deny host. When the traffic is coming from 1.2, then it is considering that if it's coming from 1.2, it doesn't matches the ACL. So the statement over here is not being satisfied. And that's why the implicit deny is blocking the other traffic. That's why we also need to add another statement that says permit others, permit any. Okay, so we will go and configure the same access list with another statement saying access list 10, okay, permit, and we will say any. And then if you check your access control list by running show access list, then there are two statements now. The first one is deny host, and the second one is permitting. The number 10, 20, 30 will be given to the statements as far like as a sequence that you type it. Okay. So now if I go ahead and see if the traffic is going blocked, from traffic, the traffic is going from 1.2. I tried sending traffic from 1.2 and it's working. But if I send traffic from 1.3, it's gonna go failed. You see that? If you enter the traffic in SE2 slash 0 in inwards, again the same thing is going to happen. But if you have other networks as well, like over here, and then the traffic will even not make it to the next router if it's there. That's why we say configure it nearest to the destination. Do you understand that now? So you need to be careful when you apply these ACLs on the interfaces. All right. Go ahead, do this small lab and let me know when you're done. Okay, the commands that are used are just like this: access hyphen list 10 permit host 192.168.1.3 and access list 10 per, sorry, this is going to be deny permit host any, permit any, and then go to interface and say IP access hyphen group 10 in. These are the commands. 1.3 can reach out over here till R2. If I send traffic from here to here, it's gonna go successful. But if the traffic tries to take an exit from FA0/0, it's not gonna work. Yeah, go ahead, do this lab. Let me know when you're done. Okay. All right. Moving on, you can fix that later. If you want to block the entire network, how would you do that? So for that, you need to specify the network ID as well. Let's say that according to our access control list that we have, if we say do show access list, then you can see that 1.3 is being denied. So we will remove this access control list entirely by using a command that says no access hyphen list 10, and the entire access list has been removed. Then, in order to configure a new access list or that blocks the entire network, I would use a command that says access hyphen list space 10 space deny, and I would specify the network ID. Along with, we need to apply the wildcard bits as well. So we will say 000255, which is kind of an inverse to the subnet mask that we use. We did cover this part while we were discussing OSPF. Do you remember we talked about how wildcard mask is done? Make sense to you? Yeah. So you need to specify the wildcard bits as well over here. And once you do that, then you can specify that any other configuration, or I would say access list 10 permit any. So these are the two. Yeah, you just inverse the subnet, and that will be equal to the wildcard mask. So you gotta have permit any as well at the second command, and you say do show access list, and this is how the config is going to look like. 1.0 can be. So I'll just add up a new network, okay, and that new network can be added on the first router itself. So I'll just take a switch here, and we'll connect a PC or a couple of PCs, and then we will make the connections from here to here to here to here, and then we will, let's say the network is 4.0. So I will go on my enable conf interface fa1/0 no shutdown IP address 192.168.4.1 255.255.255.0, and then IP DSCP pool C network 192.168.4.0 255.255.255.0. Default is 192.168.4.1. Okay, and then router ref version 2 network. I will also advertise that as 4.0, right? And then your R2 should be updated about that. So after doing this config, do show IP route can be performed, and you would see that the second route is R2. So when I try sending traffic now, according to my ACL that has been configured, if I perform do show access list, you can see, sorry, that won't be on R1. Do show access hyphen list, then you can see that the access control list can be verified like this. This is the access control list, correct? So one is deny the 1.0 network and then permit anything else. So when I get the IP addresses configured on the desktops, that would be out of the 4.0 network, correct? And then I go and configure the other, and it's working. And when I send traffic from my 1.0 network, it's gonna go failed. Any PC failed. But if I send traffic from 4.0 to over here, it's gonna go successful. Make sense to you? it's gonna go successful. So that is exactly how you use network IDs in order to do that config. Make sense to you? So you just modify the command and you say deny host uh, 192.168.1.0 along with the subnet mask. This is what the change is going to be. And then you can configure the other network as well. Okay. So yeah, try doing this as well. The lab, I'll give you 10 minutes for that. And then let me know when you're done. Then we will move ahead to the extended access control lists. All right, let's move to the next thing, that is extended access control list. So let's say that my device over here, the R1. Now I will remove all the access control list configuration from R2 by running a command called no access list 10. And I will also remove the IP access group command that I have applied, because if you say do show run interface FA0/0, or I would say do show run, then you can see that my FA0/0 has a command that is IP access group 10 out. I need to also remove this command. So I will go in my interface and I would say no IP access group 10 out, and the command will be removed. Okay, and everything is back to normal now. So I can say that I can ping from this PC to this and everything will work, and I can ping from this network as well over here. Now what we want is, let's say that our R1 has configured with Telnet. And how do you configure Telnet on this? We basically can go on R1 and let's say we configure our Telnet, but for that we also need an enable password as well. So we go ahead and configure our enable password by using a command called enable space password space Cisco. So Cisco is our enable password. Now, whenever everyone will try to log into this particular router out of from, let's say I'm completely out of any mode of my R1, and as I hit enter and go to from user mode, I try to enter enable, it asks me for a password, and this password will be Cisco, and hit enter, and then I will be able to go into the enable mode, right? Then after that, I also need to configure a telnet password and enable telnet on my device. So how do you do that? You go to conft and you select a line that says line space VTY space 0 space 4. Now, what does this 0 space 4 means? Just like we log in and go into the FA fast Ethernet interfaces, just like that, there are virtual interfaces as well for telnet. We call them those interfaces as VTY lines. So we go to those lines and we create lines from 0 to 4, which means 0, 1, 2, 3, and 4. These are 5 lines altogether, which means that you can configure your router by connecting with the telnet with the 5 users at a time. So 5 users can connect with that. And then you can say that after doing line VTY 0 space 4, you can say password, and the password for this also becomes Cisco itself. Okay, and then we say login. And after we do this, do apply this command, then I go on and say if I try to reach out from this particular PC, I will go on this PC and then I will say I will go to the command prompt, and from command prompt I will type down a command says telnet space the IP address of my router, that is 1.1. And when I hit this, it asks me for a password. This is enable password. And then, sorry, this is telnet password. And then after applying this, enable and then say Cisco, and we are good. We are inside of our router. Do you see that? So we can configure our router from any device by using telnet. Make sense? Do you understand how telnet actually works? Perfect. Then after configuring this telnet, now our requirement is that only 1.0 and 4.0 should be able to telnet to this particular router. The outside unauthorized people which are connected to 2.0 network, which is not part of the R1 directly, should not be able to telnet to the router. Do you understand the requirement? Now, for such requirement, we basically use extended access control list in which we can actually filter the traffic based on the protocols that we use. Make sense? So, how many IP addresses are there to which we can actually ping, or how many IP addresses are there from which the router 1 can be accessed via telnet? Can I say 1.1, 4.1 and 3.1? Do you agree to this? Correct? So we need to create a rule that only allow 1.0 people and 4.0 people to access our telnet feature on these IP addresses. Only allow these for telnet ones. So how do you do that? And telnet will be configured on, sorry, the access control list will be configured on R1 now. So we will go to R1 and we will say access list 101. Now, as I told you that the range for the extended starts from 100 and it goes to 199. So this will be 101, and then I need to specify whether I need to deny or permit. So we need to permit the traffic. And which protocol do we need to permit? It's gonna be a TCP because Telnet uses TCP protocol. So I would say permit TCP, and then after that I will say what is the source. So the source is a network that says 192.168.1.0 space 000.255, and the destination is going to be host. And what is the host? 192.168.1.1. Do you understand this thing? Any questions in this? So we specify that access list 101 permit TCP packets from 1.0 network that is going to destination 1.1. And we also need to specify what protocol are you looking for. So we say equal to telnet. Or if you don't want to use the telnet, you can also use port number like 23. Okay. So that's how you can use it. And you hit the enter button. Just like that, you also need to configure the same thing for another destination that is 3.1 and 4.1. These are the three IP addresses from which Telnet can be accessed, right? So we configure and we allow 1.0 to configure Telnet or to be able to ping to the port number 23 on these destination IP addresses 1.1, 3.1 and 4.1. Cool. And then we need to also allow, I would say, the other network as well, that is 4.0. But let's not do that as of now. Let's just keep 1.0 to be able to reach out over there. Okay. And we will apply this particular command on our which interfaces, on all the interfaces that are going to receive this traffic as inbound. So the traffic will come inside of FA0/0, inside of FA1/0, and inside of SE2/0. So I will go on interface SE2/0, and I would say IP access group 101 in. And then I would go to interface FA1/0 and IP access group 10 in, and interface FA0/0, and I would say IP access group 101 in. Do you understand this? 23 is basically the port number for Telnet. So we specify that what port number should be filtered out. If you want to just deny the Telnet traffic, you say deny this particular traffic for port number 23. Man, we are allowing 1.0 people. So these PCs should be able to reach out to 1.1 for doing the telnet. Okay, that's why we are saying that source will be 1.0 network and the destination will be the router's IP address, because traffic is going to come from source as a request of Telnet, and we are filtering the traffic for only protocol number 23. Do you understand that now? Exactly. So we did configure this, and as the hosts are going to send the traffic, and the destination in our access control list will be 1.1, 3.1, and 4.1. That's why we are accepting this traffic inside of all these interfaces. What would happen if these people try to send traffic on this interface? If these PCs try to ping to the R1 on 3.1 interface, which interface is going to receive that? Of course, 3.1, right? That's why we need to apply it over here as well. Do you understand that now? Good. So that's why we basically configure it over there. And now, if I kind of send traffic from, or if I try to go on this PC, and let's say I try to again telnet to 1.1, and there you go, I'm able to reach out over there, correct? And when I hit password, and I'm inside of the router. So yeah, if I can like take an exit from here, but if I go on the other PC now, which is from 4.0 network, and if I try to telnet by going into desktop and going to command prompt and say telnet 192.168.1.1, see, it's not working because 4.0 is not allowed, and so will not be allowed to 2.0. So if I go on 2.0 PC and say telnet 192.168, let's say the other PC, the other address 3.1, it will not work there as well. Make sense? Do you understand that? So only people from 1.0 will be able to reach out via telnet. Then now you can see that the communication between these hosts would also not be possible because there is this implicit deny that is working, right? We just said permit, 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 but at the last it's going to deny everything. So we need to also permit the traffic that uses this ping messages. So we will add the information, and we will also use the permit command that says IP access, sorry, access list 101, okay, permit, and we need to specify which traffic is does it use. ICMP, because ping messages uses ICMP traffic. ICMP stands for Internet Control Message Protocol. Okay, so I say ICMP, and where do we want to allow it from any to any. So we say access list 101 permit ICMP any. Okay, source is any, destination is any, and then we enter it and take an exit. And then after that, when I try to send traffic from here to here, the traffic is going to go successful. When I transfer packet from here to here, the traffic is going to go successful. But if I again go over here and say telnet, then this is going to work. The 1.1 will be able to work. But again, if I go on to the second 4.0 network and try doing that, it's not going to work. So you see that your communication is working between the PCs, but you only authorized people can telnet to R1. Do you understand this? And this is what we call as extended access control list. I hope you understand the basic use of this exactly. So I'm writing down the commands that you can use. Okay, the first command is going to be access list 101 permit TCP from 192.168.1.0 sorry 0.0.0.255 host 192.168.1 dot equal to 23. Then I will just copy this command, and I would say second command is going to be 2.1, and third command is going to be 3.1, and then after that fourth command is going to be permit ICMP any. That is going to be the fourth command. And then I would say fifth command would be interface se2/0, and say sixth command is IP access group 101 in. Okay, and then apply it on all the interfaces that you have on R1. So these are the steps that you can follow. Make sense to you? I've just applied it on one interface. You need to apply it on all the interface. So go ahead, do this lab and let me know when you're done. So I hope you're done with the lab and you understand how standard access control list and extended one works. Okay, you can research about them on Google more and learn about how ACL can be worked in some other scenarios as well. There are multiple concepts that are not covered in CCNA though, but ACL is kind of a vast topic that can be discussed for the entire day of 8 hours as well. So that was the I would say topics that we had to discuss today. Okay, and we're done with the agenda of today, and we'll continue the session tomorrow as well, where we will talk about some other IP services like and security things like port security and NAT and PAT, and then after that we will see how DSCP snooping works. Okay, those are the concepts that we're going to cover tomorrow. So thank you so much for tuning in, and I'll see you guys tomorrow as well on the same time. Thank you so much. Take care of yourself. Bye bye.